All right, let's take a look at what it takes to find the total interest made. So you deposit $400,000 each year into an account earning 8% interest compounded annually. How much will you have in the account in 30 years? Second question, how much interest will you earn over those 30 years? All right, so first off, the first question, how much will you have in the account in 30 years, is a question we've already seen, but we have to work that out for the second one anyway. So we're depositing each year. So this is not a lump sum, this is a periodic deposit. So this is a savings annuity, and we have our savings annuity formula on the right. This will increase over time, and the formula is the one with the positive exponent, which will model an increasing exponential situation. How much will we have in the account in 30 years? So we're really looking for P sub 30, how much in the account after 30 years. D is 4,000. 1 plus R is the 8%, but we know that we have to take that 8 and divide by 100. That was a weird looking 8. There we go. So our R is 0.08. N, since it says, you'll notice that it says deposit each year, and it also says compounded annually. The rate or periodicity of the deposit will always match how often the interest is compounded for the questions in this book, because otherwise the formula is much more difficult than the formula we're using. The formula we're using is already more complicated than most that you've used. All right, so N equals 1 time a year. N is 1, T is 30. We have minus 1, close the numerator parenthesis, divide by the 0.08 divided by 1. And everything on the right side is known, so we just have to work out our calculator. So it would be a fraction. Let's see, which mode am I in? Let's go to the math print mode. Fraction, 4,000, parenthesis, double parenthesis, 1 plus 0.08 fraction over 1, parenthesis, exponent, 1 times 30, parenthesis, oh, I forgot the minus 1, parenthesis, denominator is a fraction, 0.08 over 1. Now, the over 1 doesn't change anything, but I just wanted to demonstrate this formula looking exactly like we have written down. We hit enter, and we get approximately, because we're going to round to the nearest penny, $453,132.84. So that's how much will be in the account in 30 years. But we also have how much interest. So there's two formulas that we need to know that are not in the formula sheet that you want to memorize. One is the total paid or saved, depending on the situation, in this case saved, is DNT. So if we work out DNT, D is 4,000, N is 1, and T is 30. What this is $4,000 times 1 is how much per year, times 30 is how much total. This is actually how much we have saved, $120,000. So if it's a savings problem, DNT will be how much you saved over time. If it's a an annuity savings. And if it's a loan problem, DNT will how much you pay over the time. And then interest, let's see, put it over here. In our case, will be the value in the bank minus DNT. This will change if it's a loan problem. You have two numbers you're looking at. One is 453,000-ish, and the other is the 120,000. One number will be larger than the other. For a savings problem, the amount in the account will be larger than the DNT, how much you saved. So you always take the larger number, subtract the smaller number. Otherwise you get a negative, and that doesn't make sense for how much interest you've earned or how much interest you've paid. It'll always be a positive number. So you put a $sign, keep our units. So if we subtract 120,000 from 453,000, we get $333,132.84. That is the interest that we have earned on the savings account. That's nice when the bank pays us a bunch of money. Don't feel bad for them though. They turned around and loaned a lot more than that and made a lot more interest off of people. Okay, so two extra formulas that you need to know. DNT, and the DNT compared to the amount in the account, subtract the smaller one from the larger one, and that gives you your interest. Let's see how you do on this by taking a look at the question on the right. So go ahead and pause the video, work this out, see if you get it right. All right, on this problem, we first need to work out how much you end up. The monthly payment was D, and you should get $857.36. And how much you end up paying is the DNT, and that works out to be $308,649.60. This question did not ask about the interest. If you did need to know how much interest you paid the bank, the two numbers that you'd be looking at is the DNT and the amount that was originally borrowed from the bank. And you can see that the DNT is larger. And so in this case, your interest would be the DNT minus the P sub 0. Why didn't that go B? There we go. So there are two basic interest formulas, and it just depends on which number's larger that goes first. And also for compounded, it would be interest equals the larger P sub t minus the smaller P sub 0. There's no DNT because there's no D because it's just a one-time deposit. Those are your three extra interest formulas and things you need to work out that are not on the formula sheet. Again, the formula sheet will be this, growth models on the left, and these are your finance formulas on the right. No interest or DNT involved. Know those well. All right, I hope this helps.